So now, what if data are not normal? We'll get to that. What if external conditions are the same? What do? We'll get to that. So if external conditions are not same, you proceed with variance test. If the external conditions are same, you proceed with paired t-test. But what is this paired t-test? This test is used to compare the means of two sets of observations when all the other external conditions are the same. This is a more powerful test as the variability in the observations is due to differences between the people or objects sampled, is factored out, right? So normally in the previous example wherein we had full interest rate waiver and Christmas promotion, we had different set of people here. But if you had the same set of people, the variability is removed. Variation because of differences in these people. If you're manufacturing 10,000 shirts, and if you give 100 shirts to person A for audit, another 100 shirts to person B to perform audit, because of the capabilities of person A and B, the audit process might vary. But if you give 100 samples to person A, right, and if you give the same set of 100 to person B, probably you'll counter that to some extent because you're giving the same equipment, right? Or you give 100 to this person A, give another set of 100 to person A and check whether he is performing the job properly or not. And this is very much part of your measurement system analysis, wherein you give the same set to the same person again and you check with that person on whether he's performing a good job or not. But let all this be set aside. Let us understand this using this example. To find out if medication A lowers the blood pressure or not. Take 100 people from Mumbai. So you're taking 100 people from Mumbai and another 100 from Chennai. And both of them have high blood pressure. Administer medication A to 100 people in Mumbai, give them the medicine to these 100 people, and to another set of 100 people who are in Chennai, give a placebo. What is placebo? Placebo is psychological medicine. If you go to doctor and say that, hey, I have too much flu, cold, right? Then doctor also knows for a fact that within 7 days, there won't be any cold. The virus would die down. But just to give you that psychological, strength, doctor would give you some medicine, which really doesn't have any impact, basically, right? Significant impact would not be there. But still you get the psychological strength that, yeah, there is something going on, I'll get well, right? That's called as placebo. So we need to compare the new blood pressures between Mumbai and Chennai participants. Since you're trying out medicine A on Mumbai, and since you're trying out placebo on another, 100 Chennai patients, since you're doing that, since these two people are different, the external conditions are different. But think about this for a change. Say you're taking 100 people from Mumbai, right? Only those of them who have high blood pressure, you have chosen them and you have given them medicine A. And you have, tested, experimented on them for 6 months. and then for the next 6 months you give the same set of people placebo and then try out whether medicine A was effective or not in comparison to placebo. And here you're trying out on the same set of 100 people, and in this scenario the external conditions are said to be the same. Right? And this is whenever you have external conditions which are the same, since you're doing on same set of people, it's called as paid t-test. And since here you have two different set of people altogether, this is sample 1 and this is sample 2, we call it as two sample t-test. Now let me try to surprise you all with some kind of quiz here. Comparing the performance of machine A versus machine B by feeding different raw materials to each machine. Should this be a two sample t-test scenario, or should it be a paid t-test scenario? So we need to think a lot. We are trying to compare the performance of two machines by feeding different raw materials. Since you're feeding different raw materials, external conditions are different. If external conditions are different, we proceed with two sample t-test. On the contrary, if we are comparing the performance of machine A and machine B, when the same raw material is fed to each machine, then the external conditions are the same. Then we tend to perform paid t-test. Okay. Compare the power output of two windmills next to each other simultaneously when you use motor A on one windmill and motor B on another. So you're placing two windmills next to each other. You're simultaneously using motor A on one windmill and motor B on another. You want to see whether motor A is better or motor B is better. But since the two windmills are placed next to each other, the external conditions would not be, or external conditions would be the same. If there is too much of air pressure, right? High temperature would impact both the windmills. If there is heavy rain would impact both the windmills. So the external conditions are the same, hence you perform a paid t-test. However, if you compare the power output of a windmill when you use motor A for 1 month, this 1 month might be dry season, it might be summer season, no wind absolutely maybe, and motor B for 1 month, and maybe in this 1 month it's some kind of winter season, a lot of winds are blowing, so the external conditions vary, hence we perform two sample t-test. Identifying resistor defects and capacitor defects in same PCB by collecting such data using 20 PCB units, right? So since you're using same PCB units, external conditions would be the same. So we end up using paid t-test. But if you're identifying resistor defects on 20 PCBs and capacitor defects on another 20 different PCBs, then the external conditions will vary and we implement two sample t-test. Yeah. So let us give a try and understand this. Effect of fuel additive on vehicles is being studied. Out of the 20 vehicles, 100 vehicles are, out of 20 vehicles, 10 vehicles are chosen randomly and mileage is recorded. In the rest of the 10 vehicles, additive to be tested is added with the fuel and their mileage is recorded. We need to find if the mileage increases by adding the fuel additive. Given this context, which test are we going to perform? Yep, I'm assuming you all got it right. It's two sample t-test because on 10 vehicles you're not adding the additive. On another 10 vehicles you're adding the additive and then testing. So these are not the same vehicles, these are two different vehicles. The moment you have two different set of vehicles, right, then its external conditions vary and hence we implement two sample t-test. Now assume that same data was recorded if only 10 vehicles were chosen. So you choose 10 vehicles and mileage was recorded before and after adding the additive for these 10 vehicles. Since the external conditions do not vary, in this scenario, if this statement is added, we proceed with paid t-test.